Today we will be discussing more on syntax directed translation schemes. What is a SDT? So we have already discussed that within the production, okay, if we have enclose some program structures or fragments, it is called syntax direction translation scheme, and that program fragments are called semantic actions. An action can be placed at any position within the body of a production, and it is performed immediately after all symbols to its left are processed. Now, if we have a production B giving X A Y, then the action of A is done after we have recognized X. And this action, semantic action, can be placed anywhere on the RHS of the production. So this is what we have discussed in the last tutorial itself. Now, we will see an SDT for converting infix to postfix. Now, this is the SDT. So it's the same as that of the desktop calculator. SDT for desktop calculator we have seen in the last tutorial. We have some modification to this, including some program fragments. Cell giving en, then e giving print plus, then e1 plus t. Okay, first we have to print plus, and then we will be going to e1 plus t. Then e giving t, then print t giving print star, then t1 star f. Okay, then t giving f giving evaluating expression, and f giving digit. That is, we have to print the lexical value of the digit. Okay, so let us see with an example. Now I have to convert this expression to postfix notation. This is infix notation. I have to convert to postfix notation. So 2 plus 3 into 4. So I have written the productions that I am using for this conversion. I want E giving E plus T, then E giving T, T giving T star F, T giving F, and F giving num. And I have returned that semantic actions here, and I have numbered those productions. Okay, so for evaluating this, how I should write the prediction: E giving E plus T, then T giving T star F, and all T's giving F and F giving num. This is how we can evaluate. This is a corresponding parse tree. Now what's the next step? I have to give a number of each of the semantic actions. Okay, so here F giving num is the semantic action 5, so I have to number it as 5. T giving F, it is semantic action 4, so I have to number it as 4. So I have given this production, each of the semantic actions a corresponding number. So F giving number 5, T giving F4, E giving T2, and E giving E plus T as E giving E plus T as 2, and E giving E plus T 1. Sorry, E giving T is 2, E giving E plus T is 1, T giving T star F is 3, and F giving num is 5. Similarly, T giving F is 4. Similarly, I have given every semantic actions the corresponding numbers. Now, next, so how will we do this parsing? We will perform bottom-up approach. So from top to bottom and from left to right, we will pass. So when I come across top to bottom, first semantic action that I have to perform is action number 5. So what is action number 5? Print num dot lexical value. So what is the lexical value of number here? 2. So I have to print that lexical value. So I have printed 2. After this, what is the semantic action to be performed? Number 4, right? We are from top to bottom and from left to right we will go, right? So after 5 I have to do 4. So 4, this is empty, that means I don't have to do anything. Okay, now moving on to 2, what is the semantic action? It is also empty, so no action to be performed. Now after this I am going here, then again I am coming to bottom. So when I come to bottom, what is the next semantic action? Number 5. So number 5 is print num dot lex value. So here lexical value of this number is 3, and I am printing it. Now again moving on, I have 4. 4, I don't have any action. Now I came across star, then I came across F, and then again to here I will come across less as semantic action 5. So here semantic action 5 is print lex value. So here lex value is 4. I will print 4. After this, I am going to 3. So what is 3? Print star, right? So I will print star. Then moving on here, I will get 1. What is 1? Print plus. So thus we have converted this expression to corresponding postfix expression. So similar to last tutorial only, we just gave semantic action numbers and then perform this bottom up parsing approach. Thus we will get the corresponding value or answer. Okay. Now we will see how we will perform bottom up evaluation of S attribute definition with the help of a stack. Okay, so SDDs with only synthesized attributed attributes can be evaluated by a bottom-up parser as input is passed. So synthesized attributes, you know what is synthesized attributes, right? We will get the value of those attributes from the child, right? So in this approach, what we'll do is we will keep the values of synthesized attribute associated with grammar symbol on its stack. So the attributes value we will keep it in a stack, and a stack will have two information. It's kept as a pair. It will consist of a state and the corresponding value. And whenever a reduction is made, we will consult the stack and will perform the necessary action. Okay, so when a reduction is made, the value of synthesized attribute are computed from the attribute appearing on the stack for the grammar symbol. And implementation is by using an LR parser. Z. So this is example A giving XYZ. Okay, so I have this stack here. Okay, A giving x, y, z. So first I will push x and the corresponding value is x dot x. Then I will push y, corresponding value is y dot y. And I will push z, the corresponding value is z dot z. In this particular diagram, top of a stack is shown here. Okay, so this is another one. Same thing, where top of the stack is on the top. So this is a pointer to the LR1 pass table. Okay, and this is the corresponding value. So I am pushing XYZ. Okay, after pass, during pass, what will we do is this XYZ will be popped out. Okay, whenever we get a reduction, I'll pop out this XYZ and will replace by A. That is why I have, after the pass, I have capital A here and the corresponding lexical value here. So this is by using stack. We will see an example. So this is an implementation of our desk calculator with an LR parser. Now L giving en, in that we have to print value of top, that is whatever value is on the top we have to print when we come across this production. So when we come across this production, the action that we have to take is print the value on stack top. Then E giving E1 plus T. Okay. Whenever we come across this production, what you have to do is you have to pop the values, three values from stack top. That is value on top minus 1, and value on top minus 2. Then you have to perform value of top plus value of top minus 2. Okay, then you have to add it and it will be stored as value on top. That is, if you have e giving e1 plus t, you have to pop three variables from stack top. Okay, perform the addition of stack top and stack top minus 2 and store the resulting value on stack. And e giving t, no action. T giving t1 star f, similar to this, but instead of addition we will be performing multiplication. T giving f, f giving expression. So when we get this, the value of the top minus 1 will be taken as value on top. Okay, they will be popping the topmost symbol. So T, this is an example of E giving E plus T. So have e plus t over here. So what we have to do, this is the stack top now. This is top minus 1, this is top minus 2. So when you get this prediction, have to pop these three symbols, perform the value of t value plus e value and store it as e dot value in stack top. Okay. So have to see how we can pass an input string 3 into 5 plus 4n. So these are the predictions that I am using. L giving En, E giving E plus E1 plus T, E giving T, T giving T star F, T giving F, F giving E and F giving digit. These are the semantic rules corresponding to the prediction. Okay, and this is the code fragment. Okay, so if I am having an L giving en, I have to print value on top. Even plus t, I have to pop the top three symbols, perform addition of first and last one, and then have to again push it on the stack. Similarly, it's for multiplication and last for the expression. So let us see how we will traverse through this one. So this is my input symbol, this is the stack. Okay, this is the state and this is the value, and we'll be using these predictions. So first input symbol is 3. Okay, this is our string 3 into 5 plus 4 and so first is 3, so I am moving it to the stack. The value is 3. So when we have a digit lol x value, then what is the prediction? F giving digit is the prediction. So I will replace this by capital F here. Value will be 3. State is changed to capital F and prediction used is F giving digit. Now next if we have f, it has to be because we are performing or bottom up approach, right? So if we have f, I have to replace it by t. That is why I have written a production t giving f and f is replaced with t here. Now after 3, next symbol is star, so I have written star. Now we don't have any predictions corresponding this one. Now since the state has two symbols over here, that is stack state has two symbols, so I have to include two symbols. That is why I am including it as a blank. I am giving a blank symbol over here. Now next is 5. So when I have t star 5, so when I have 5, what you have to do, if I have a digit or x value, I have to use the production f giving digit. So 5 will be replaced by f and the value 5 will be added here, right? Then again f will be replaced by t. So again here f is replaced by t. So next what I will get, t star f is the prediction that I get. So whenever I have a prediction like t star f, what you have to do, perform t that pop three numbers, then perform the multiplication of top and top minus 2. So I have written as 15. Okay, then again after this, what is the next symbol? Now e, after this, after performing this, whenever I have a t over here, I have to write e giving t. That is why I have written e giving t, and the state has changed from t to e. Okay, we are doing the bottom up evaluation. That is why we have written t is replaced by e here, right? Now again plus is the symbol, I am pushing it to the stack. So when I have a plus, I don't have anything. So since the stack top has two symbols, I have to make a space for symbol here, so one blank is there, right? Now next one is 4. So again whenever value is there, I have to substitute it by f, and it has to be substituted by t. So I have e plus t. So whenever I have e plus t, it is substituted by e, and you have to perform the t stack top and top minus 2's value, so addition. So it is 19. Okay, so e will be replaced by en and en will be replaced by l. So l giving en is the prediction used and the result is 19. So this is a bottom up evaluation using the stack. Now let us see top down translation. In this case of top down translation, we will be using L attributed definitions. So as we have discussed earlier, attributed definitions will consist of both what synthesis attribute as well as what the attributes, the inherited attributes, right? That we have inherited from parents or siblings. So in that case, there is a chance for left recursion in those grammars. The first step is you have to eliminate those left recursion. For example, is E giving E plus T, giving E minus T, giving T, T giving E and T got T giving num have left recursion here. The first step is you have to eliminate the left recursion. So we have discussed how we have to eliminate left recursion. So this is the prediction that I get after eliminating the left recursions. So I am replacing this with another variable, right? So E giving tr and r giving plus r1 and r giving minus tr1 I will get after eliminating the left recursions. Now I am writing this semantic actions. So here we can see r dot in is there, r dot s is there. So what is the meaning? This in means it is an inherited attribute and s means it is a s attribute. Okay, so that is what you have to specify here. So e giving tr. So when I have e giving tr, what I have to perform semantic action is uh, the value of r is inherited, right? Because we will get r value directly. So r in equal to t value. Okay, r dot inherited is equal to t dot val, and e dot val we will get from r dot s. Okay, hope you are clear with this. This is inherited value. It is passed to t value, and the e value it is uh, what it will get from this r dot s. Okay, synthesize attribute value of r. Now here let us see. First r1. R1 is inherited value. It is added to t value. Okay. Then this is the synthesized value of r1 because r1 is r1 plus t. So that is given to r. So r dot is equal to r1 dot s. So when you know the concept that is synthesis attributes are attributes that is that we get from the children, and inherited attributes are attributes that we get either from parent or from siblings. That is why this is r dot in. It's inherited attribute. Okay, is equal to t val. Okay, from t it gets. Okay, then this one e dot val is equal to r dot s. This is synthesis attribute. Similarly, I have written everything here. Now, this is an example of evaluation of 9 minus 5 plus 2. Okay, so here 9 minus 5 plus 2. In order to get this, I have to use the predictions E giving TR, R giving minus TR1, and R giving plus TR1. Okay, this is by using the grammar after eliminating the left recursion. Now, this is a flow of how the variables are what evaluated. So first from starting from top to bottom. Now this num dot val equal to 9. So this is passed to t val and this is over passed to r dot I. Okay. The num dot val is again as an in synthesis attribute, right? So it is given to t dot val. Okay. So this has got 9. Now after this, okay, so this is 9. 9 minus 5 is given to r dot I. So 4 it gets to is given to r dot I. Then again this num dot value is 2. This 2 plus 4 is given to ri. So resultant value is 6. So hope you have understood the concept. Thanks for watching.